Hello everyone, welcome to today's session on light about reflection and refraction. So in reflection and refraction, we have already learned about reflection and also refraction. And today we will look at how the refraction happens in different lens, like the convex and concave lens. Okay, so first let's look at. So we learned about the mirrors, right? Convex and concave mirrors. So here, if a material, if 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 a material is convex at one shape and flat at the other side, if the mirror, right, or a mirror or a glass material that is convex at one side and flat at one end, that is a convex lens. If I put two convex lens together, that's a double convex lens. Okay, so this together called a convex lens. Okay, we can call it as a double convex lens or a convex lens. And similarly, the flat on one side and concave on the other end. If I add another such mirror, that is like a double concave lens, or we also call it as concave lens. Okay, so going forward, we will not refer it as a double convex lens or anything. When I say convex lens, this is convex lens and this is concave lens. Okay, so it is a glass material, right? So how the light ray behaves in convex lens. So before we get into the details, let's understand that these lenses have two curvatures. Okay, so two curvatures means, let me extend this principal axis, right? This is the principal axis, the PA, and the center of the lens is O, right? So that is the center of the lens. And if we look from this side, we have the curvature to this side. That means the center of curvature is somewhere here. That is called C1. Okay, and if you look from this side, the center of curvature is here. Let's say that is C2. Both should be at the same distance from the center. Now, in between, there is a focus point, that is F1. And at the mid of it, there is a focus point, that is F2. Right? So compared to mirror, the only difference here is you will have two centers on either side. Then this is also called as 2F1, because F1 is the midpoint between O and C1. So this distance is 2F1. So in lens, we mostly refer about 2F1 and 2F2. When I say 2F1 and 2 times of F1 and 2 times of F2, that is nothing but C1 and C2. This is 2F2. Okay, this is what we will refer. 2F1 means the center of the curvature. Now, what happens if a straight line, right? If a straight line parallel to the principal axis hits the convex lens, what will happen is it travels through the focus point on the other side of the lens. You understood? So if a parallel line travels and if a parallel line incidents on the convex lens, right? So this is convex lens, right? So when a parallel line hits on the convex lens, which is parallel to the principal axis, so this is PA, that's the principal axis, the light ray converges and passes through the focus on the other side of the convex lens. Okay, so like that, if you see in the diagram here, if a parallel beam of light is incidenting on the convex lens that is converging at F2, that forms a point image. Okay, that forms a point image at F2. So let's look at like how the parallel ray behaves, how the inclined ray behaves, all that stuff, right? So this is about convex lens. Now, so what happens if the line incidents through the focus, right? So this is O, and let's say this is 2F1, and this is F1. So as I said, going forward, I will not refer to C1, C2. I'll just refer as 2F1 and 2F2. Now, what happens if a light of ray passes through the focus and incidents on the convex mirror? Then it emerges out as the parallel ray to the principal axis. So when a ray incident through the focus, that emerges out, that refracts out through the lens parallel to the principal axis. So that's one scenario. We saw a parallel line incidenting is converging through the focus F2. Now, if a light ray is passing through F1 and falling onto the convex lens, that is emerging out as parallel to the principal axis. Now, there is another scenario. So let's see what is that scenario. If a light ray, what happens if a light ray passes through the center of this, right? So they say this is F1, this is 2F1, and let's say this is F2, and this will be 2F2. And what happens if a light ray incidents and such a way that it passes through the center of the lens? So it goes undeviated. This is important, guys. So a ray incidenting onto the lens, which is passing through the center, which go undeviated in the same direction as a straight line. Okay, so three scenarios we covered. One is a ray parallel to the principal axis that converges through F2, and a line which is coming through F1 that will emerge parallel to the principal axis, and a light ray which travels through the center of the lens that will go undeviated as a straight line. Okay, now based on this, we can draw the images, right? So how the images are formed in convex lens, right? So first, let's put the structure of the convex lens. So we have F1 and 2F1 to one side, right? And then let's say this is F1 and this is F2. Sorry, 2F1. This is 2 times of F1. And this is F2 and this is 2F2. These are equidistances. Now, what happens if an object is at infinity, right? So let's say this is object AB. If a parallel beam of light incident onto the convex lens. So what will happen if a parallel beam incidents onto the convex lens that converges through the focus on the other side, that is F2. So what type of image is forming here? It is forming a what image is being formed? Position of the image is, if the object is at infinity, the position of the image is at F2. And what is the size of the image? That is highly diminished or point size image, right? This is point size image, or we can also call highly diminished image. And also, what is the nature of the image? So it is a real image. It's a real image and inverted. Okay, guys. So if the object is at infinity, we will get a point size image that is highly diminished, and that is real and inverted. Okay, now let's look at the position of this. So let's see, I'm drawing with free hand, so it may not come exactly as we draw with the scale. So this is F1 to F1, this is F2, and here it is to F2, and this is the center. So where is the object now? The object is beyond 2F1. Okay, so I have the object somewhere here, right? So let's say this is AB, which is beyond 2F1. Now what I'll do is I'll send a parallel ray to the principal axis that should by the rules, it should converge and move from the F2. That's right. Now, if the same, I need two rays to form the image, guys. Okay, so one is passing through the center. If an image passes through the center, what will happen, guys? So it will not deviate and it go as a straight line, right? So what is happening here? If the object is beyond 2f1, then where these are intersecting? These are intersecting between f2 and 2f2. So this is my a dash b dash. So AB is the object, right? And a dash b dash is the image form. So how is this image formed, guys? So the position of the image is between f2 and 2f2. You should write between, right? So the position of the image is between f2 and 2f2. And what is the size of the image? The size of the image is like, is it what size of the image this is, guys? Like, is it enlarged or diminished? I think it is diminished. If we draw with the scale, you will exactly see that it is a diminished image. As I am drawing with free hand, so I am not getting the straight lines. Okay, so you will not see considerable difference, but it is diminished image. Okay, and the nature of the image is it is real image and inverted. Hope you are clear, guys, right? So when it is at infinity, what we will get? We will get a point size image. If the object is beyond 2f1, we are getting an image between f2 and 2f2, and that is diminished and real and inverted. Now, at 2f1. So what will happen if the image is at 2f1? Sorry, the object is at 2f1. So let's see. So for example, this is f1 and this is 2f1. And what we are saying is the object is at 2f1. Let AB is at 2f1. And this is f2 and this is 2f2. So what we need to do, let's put two incident rays. So this should go from F2. That's right, guys. So this ray should go from F2. And the other ray, if I pass through the center, that should go undeviated, right? That should go undeviated. And basically it touches, hold on, guys. So basically it exactly touches up. It's funny. Hold on. So ideally, that intersection will come here. So, okay, that intersection should come here, guys. Okay. So where is the image is forming? When it is at 2f1, the image is forming at 2f2. If you draw with the scale, you will exactly get that. Okay. And what is the size of the image? It is the exact size we will get. It is the exact same size we will get. And what is the nature of the image? It is real and inverted. Real and inverted. Okay, now let's look at the next scenario. So here the object is between f1 and 2f1. Okay, let's draw these. Let's indicate the f1, f2. So let's say this is f1 and this is 2f1. And this is f2 and this is 2f2. All right. So if the image is between f1 and 2f1, that means somewhere in the bit in between here. This is AB. So let's do our standard one ray incidence. Incidence parallel to the principal axis. So basically what will happen? it should travel straight from the F2 through F2. Now, if the same incident ray passes through the center, then it will go undeviated, undeviated, and should touch somewhere here. So if I see here, so what is basically happening here? So the image is forming, let's say this is A dash and B dash. If you draw with the scale, you will see it, guys, exactly. So here, AB is the object, and A dash B dash is the image. So where is the image forming? The image is forming beyond 2F2. If the object is between F1 and 2F1, the image is forming beyond F2. So what is the position of the image? That is beyond 2F2. And what is the size of the image? If you see, guys, AB is smaller, but A dash D dash is much bigger. So it is enlarged or magnified image, enlarged or magnified. So we'll see a bigger object, right? And also, what is the nature of the image? It is a real image and inverted image. So it is real and inverted. So hope you are following, guys. Okay. Now let's look at the other scenario, right? So what is the other scenario? What happens if the position of the object is at F1? Okay. So let's put our standard diagram. So let's say this is F1 and this is 2F1. This is F2 and this should be 2F2. So where is the position of the object? The position of the object is at F1. So this is our AB. So same thing, draw two. One is parallel to the principal axis. That means this ray should go from here, right? From the F2. And the other ray, if I go parallel, sorry, through the center, then it goes like this. So what we can observe here is if the image is, if the object is at the focus, which is F1, then the image is going like it will form at infinity. So we don't know, it is like a very big image. We may not be able to see. So what is the position of the image? Position of the image is at infinity, right? So they are not meeting each other. Then what is the size of the image? Size of the image is highly enlarged. It is highly enlarged or magnified image. And then nature of the image. So it is still real and inverted. So in convex lens, so far all the images that we got is real and inverted. So hope you understood, guys. So we looked at the object at infinite, the object beyond 2F2, the object at 2F2, the object between 2F1 and F1, and now object at F1. Now in the next case, next scenario is the object, what happens if the object is between the F1 and the center? So let's see, this is the peculiar scenario in the convex lens where we see a virtual image. This is the only instance where we see virtual image in a convex lens. So this is 2F1, this is F2, and somewhere here, this is 2F2. What happens if I have an image somewhere here? So this is A and this is B. So a ray of light is incidenting parallel to the principal axis. So ideally, it should come out through the focus on the other end. Now, what happens if the light ray passes through the center? So if you see on the right hand side, these rays are going like divergent. So they will never meet. So what we can do is, what if I project these rays to be like an imaginary rays? So what I will see is a virtual image is being formed at the same side of the lens, which is an enlarged image. This is our A dash and B dash. So what happens here is this is the only scenario where we will see a an virtual image. So what is the position of the image? So the position of the image in this scenario is basically on the same side of the lens. It can be anywhere on the same side as object, you can say, and the same side as object, and the size of the image is enlarged or magnified. Right, guys? And then what is the nature of the image? This is the only scenario where we will get a virtual image in a convex lens. And virtual and also the difference is erect. So far in all the scenarios, what we got an inverted image. So only in this scenario, we get a virtual erect image and it is enlarged. And the image is on the same side as of the object. So here, AB is the object and A dash B dash is the image. So hope you're following, guys. So we covered many scenarios, right? We covered many scenarios. So let's do a recap of all these, right? So this table from your textbook gives the summary of all the scenarios and the position of the object. So when the position of the object is at infinity, then our position of the image is at focus, which is the highly diminished or point-sized image, that is real and inverted. When it is at beyond 2f2, then the image is between f2 and 2f2, that is diminished, real and inverted. And when it is at 2f1 or c1, which is the center of curvature, the image forms, the same size image will be formed, that is still real and inverted. Between 2f1 and f2, then the image is forming at beyond 2f1, right? So beyond 2f1, it's enlarged and real and inverted. So what happens if it is at focus? When the object is at focus, it forms at infinity and image would not be formed, right? So we cannot see that image. So it is like somewhere, right? We cannot see that. And then between focus and optical center. So what happens between F1 and O? So what happens is, this is the special scenario where we get a virtual and erect image. So far what we saw is real and inverted in all the scenarios, except this case, the last scenario where the object is between F1 and O, we'll get the image on the same side, that is a virtual, enlarged and erect image. So this is very, very important, and all your board exam questions are based on this convex lens and type of images formed, where and what is the size, right? So yeah, the ray diagram. So they may ask like, what is the image? Draw a sketch to formulate the image when the object is beyond 2f1 in a convex lens, like that, right? Okay. All right, guys. Then what are the uses of convex lens, right? So you know the magnifying glass, right? So the magnifying glass, we will see the small objects in the bigger way, right? Or small objects as bigger magnified objects or an enlarged object. So in the magnifying glasses, we use convex lens. And also the eyeglasses, the spectacles. So far-sighted. So we have short-sightedness and far-sightedness. So short-sightedness, we will use a concave lens. For the far-sighted things, we use convex lens. Far-sighted means you can see the far objects, but not the close objects. So that we will get for our grandparents like that. Okay, so in those glasses we will use convex lens, and also all the camera lens. Camera lens, we want real and inverted images are formed. So that is, in camera lenses we use convex lens, and the microscope, telescope, right, and the projectors, right? So in projectors, what we need? We need a real image and an enlarged image. So real and enlarged image we can form using convex lens. Then human eye. So our eye. Our eye shape, if you see, it's like a spherical outside, right? So our human eye is a convex lens. So that converges our focus onto the retina. Then optical instruments, yeah, like magnifiers, binoculars, all those stuff, or with convex lens. All right, guys. So so far we learned about convex lens and how the images are formed and what are their uses. Now let's move to concave lens. Okay. So here in concave lens, right? So the same case, right? So the concave lens are also double lens, double concave lens. This also has an f1 and 2f1. And similarly, we have f2 and 2f2. So what happens in concave lens? In concave lens, if you send a parallel beam, a parallel incident ray coming parallel to the principal axis, incidents on the concave mirror, that should basically, sorry guys, this is not the case. So in concave mirror, it basically diverges out. So if you see that diversion, if you see from the other side, it appears that it is coming from the focus point F1 itself. If you do an imaginary line. Similarly, if let's say you have another parallel line that is also like diverging out on the other side, but it appears that it is coming from the focus F1. So in concave lens, basically what is happening is a virtual image is always formed. Okay, if a parallel beam of light is sent, a virtual image is formed on the same side, that is virtual, and that is at F1. It's a point size image. All right, so that's about the parallel ray. Now, what happens? What happens if the light ray, if the light ray passes through the center? That's one scenario, and passes through the F1. Sorry, guys, hold on. So this is 2F1, this is F2, and this is 2F2. So what happens if the light ray is passing, if the light ray is passing through the F2, okay, light ray passing through the F2. Let's say I have an incident ray which is falling like this. If I project it, it appears that it is coming from, it is incidenting to F2. But what happens here is this type of ray emerges parallel to the principal axis, emerges out parallel to the principal axis. So that is, if an incident ray incidenting onto the concave lens that appears to be from going into F2, that type of ray emerges out parallel to the principal axis. Now, same case here, if the light ray is going through the center of the lens, that go undeviated from the center. So this is same in both concave and convex lens. So these are all concave lenses, right? So three scenarios, right? One is a parallel ray incident that is like diverges out on the other side, but it appears that it is coming from the focus F1. And what happens if a ray incidenting at certain angle, that ray is appears to be going into F2, that ray will diverge parallel to the principal axis. And if it goes through the center of the lens, so that will not deviate. Now, let's see how the images are formed and the scenarios we have for concave mirrors, similar to what we saw in convex mirrors. Okay, now let's say this is F1 and this is 2F1 and this is F2 and this is 2f2. All right. So what is the position of the object here? The position of the object is at, say, infinity. So let's say this is AB. So when the object is at infinity, I'll draw two rays, one at the top and then one at the bottom, which is parallel to the principal axis. So when it is parallel to the principal axis, what will happen is it diverges out, right? But that diversion will appear that it is going, if we extend it, it appears that it is coming from the focus point F1. So here basically, if we extend the line, we can see it. Otherwise, on the right side, we don't see where it is merging. So what will happen is, what is the position of the image? The position of the image is at F1. What is the size? It is the point size image. And then what is the nature of the image? The nature of the image is virtual, right? So this is basically a virtual image, and it is like a erect image. It is virtual and erect image. Now let's move to the other scenario. So here the object is, there are only two scenarios in concave lens, but in convex lens there are many, right? So let's say this is F1 and this is 2F1 and this is F2 and this is 2F2. Now the object is between infinity and O, so it can be anywhere between infinity and O. Then let's see where the image is formed. Let's say I have the object here. Let's say this is A, B. Now what I will do, I will send a parallel incident ray. So that should what? That should diverge out, and that diversion should appear that it is coming out of F1, right? And then let's take another incident ray. This time it's going through the center. So on the right side, if you see, these two rays are diverging out, so they never meet. So that's why we need to look at where the imaginary line is meeting. So the imaginary line is meeting here. So that means this is my A dash and this is my B dash. So this is basically AB is the object and A dash B dash is the image. So what are the characteristics of these A dash B dash? So the position of the image is, it is forming between O, that's the center, and F1. So wherever the image is, wherever the source is, the image will be formed between O and F1. And what is the size of the image? The size of the image is diminished. So we'll see a smaller image compared to the object. It is always a diminished image. And the nature of the image is, it is virtual and erect. So in concave lens, there are only two scenarios. One is, let's summarize here. So in the concave lens, there are two scenarios. The position of the object at infinity. If the object is at infinity, then the position of the image is at F1, which is like a point-sized image, and it is virtual and erect. So what happens if the position of the object is between infinity and the center of the concave lens? Then the image is between F1 and O, and it is a diminished image, and it is virtual and erect. Then what are the uses of concave lens? So the concave lens, as we discussed earlier also, the main application is eyeglasses, that's spectacles. So all short-sightedness, generally the students or younger people, whoever gets the sight, right? Problems, eye issues. So that's the nearsightedness. So for that, the correction can be done using the glasses that we use in spectacles are made of concave lens, that is myopia. Then we have door mirrors, lenses in the doors to peep out like who is outside the mirror, sorry, outside the door. So that give the wide angle, right? It covers the large area outside the door from a small lens. So that is our concave lens. And similarly, the lasers, the cameras, few cameras which require a smaller image. So that can be concave lenses can be used on flashlight, torches, right? So what torch need to do? Torch need to give a uh, give a light as a parallel beam. So that can be by concave lens, right? And then the combination of concave, yeah. In few cases, we use the combination of both convex and concave lens. For example, telescopes and microscopes and cameras. Sometimes we use only convex lens, only concave lens. Sometimes if we need a combination of image formation, then we can use both in combination, like one convex lens and one concave lens together. So that type of applications we have for concave lens. So I think in this session, what we learned, guys, so we looked at the convex lens and how the images are formed in various scenarios and their application. And similarly, we looked at concave lens, how the images are formed in there are only two scenarios and what are the uses of concave lens. So that's all for today's session, guys. I hope you understood the topic, and I'll see you next time. In the meantime, if you have any questions or concerns, right, you can reach me on my Urban Pro profile. Thank you, guys.